Eyeballs. Eyeballs. Now see, I'm watching you. You gotta be paying attention right here. So we're gonna show you the flight controls, the primary and secondary flight controls of this New Zealand made aircraft. Okay, it's a little bit different than American made Cessnas, but the flight controls basically work the same. Okay, we're gonna talk about how the pilot has his controls and he puts input into the controls, and then how that relates out to the wing. Okay, so just follow me on this aircraft. This is the aileron. There's the left and right ailerons, and we're going to go over in a little bit and show you exactly how the ailerons work. Okay, they're on the outboard and the aft side of the wing itself. That's the primary control to make the aircraft bank one way or the other. Okay, we're going to go over and talk about the elevators. Another primary control is the elevators. Okay, these are the elevators. They're on the back wing right here. There's the left and right as well. It banks up or down. So this would make the aircraft pitch up or pitch down, depending on what the pilot's looking for. The third primary control is the rudder. We talked about the rudder, okay? So the rudder, when it turns one way or the other, which we're going to show you in a minute, it's going to take the aircraft and it's going to make the aircraft turn this way or this way, okay? So there you have it. What you have is the three primary flight controls. All right, so what's going to happen here is the ailerons, which we just talked about, you got left and right ailerons. The ailerons is going to make the aircraft bank right or bank left, okay? The elevators in the back, the elevator is going to make it pitch up or it's going to pitch down, okay? And then the rudder in the back, when the rudder turns, it's going to make the aircraft go in the right direction or the left direction. And that's how the flight controls work. We're going to show you a little more right now. Okay, so here we are inside the cockpit, and remember this is a New Zealand manufactured aircraft, and it's a little bit different from the American Cessnas, but it's basically all the same. All these flight control inputs these yokes are in tandem with each other. Remember now, it takes all these controls and all these push-pull tubes and pulleys and cables to make all this work to go to the outside, from here to the outside of the wing itself. Okay, so if the pilot at this point was trying to input to the outside ailerons and he wanted to turn left, he would just turn left. All right, when he does that, you notice that the co-pilot does the same. It turns with him. Okay, and then he would center back up. And if he needed to turn right, he would turn right. Just kind of like driving a car right there, huh? Okay, so they center up. Now, if he needed to pull up real fast or needed to pull up at this point, he just pulls back like that. And when he pulling back like that, it would make the elevators go up and make the aircraft nose up. And if he has to nose over, he'd go back in a normal flight, and about right there, and he would be in trim flight, cruise flight at that point. But he needs to nose over, so he would push the control in. By pushing the control in, it pushes the elevators down and would nose down. Okay, so this is what you got when you're inside. Okay, and so it's the same with the rudders as well. If the pilot was to put input into the right rudder, you see it goes to the right side. The same happens over here. The linkage goes back, and the right rudder pedal would go. If he pushes the left rudder, then he would go to the left rudder. That would turn the aircraft to the left, in the left direction, and he would put it back in neutral. All right, so I'm going to show you how, with the pilot control, how it looks like on the outside of the aircraft. Okay, so we're on the outside of the aircraft now, and we just showed you how the pilot puts input into the controls. And so now I'm going to show you through there again, through linkages, push rods, cables, turnbuckles. It's just all kinds of different devices it takes to get from that control where the pilot is out here to the wing to make it happen. So let's look what happens when the pilot puts right aileron, he turns right. And this is what you get. The aileron goes up. See how the aileron goes up? And the left aileron, which is it's hard to see, it goes down. Okay, this would let the aircraft bank to the right because the high pressure of the wind would come over the top, pushing the aircraft to the right. Okay, and I'm going to walk over here right fast. So when the pilot inputs control into the yoke and he wants the ailerons and he wants to bank left, he turns left. Now the left aileron goes up, and now the aircraft would bank left because of the air pressure on the wing. Okay, now this leads us to the elevators. So the elevators is what makes the aircraft go up and down. Okay, nose up, nose down. Good. And so if the pilot wanted the aircraft to climb, he would pull back on the control stick, elevators, the control stick, and the elevators would deflect like that. The airflow over the back of the wing would force the aircraft nose up, and the aircraft would start climbing. Then the pilot gets where his attitude he wanted to, then he'd put it in neutral, and the aircraft would go straight, fly straight. Then all of a sudden he needs to nose over and land. He just pushes the control yoke in, like we talked about, and the aircraft would nose over, and he would get to his desired altitude, and he would put it back in neutral, and he's flying level. All right, so that's your ailerons and that's your elevators. The third primary we talked about is the rudder. Remember we talked about the rudder pedals, how it goes left and right? Well, that's exactly what we have here. So if the pilot puts right rudder in, the rudder turns to the right, and it would cause the aircraft to turn in the direction of the right. It would actually turn to right, not bank, but turn the aircraft nose to right. And then he would center it back up in neutral position after he got it desired. And all of a sudden he needs to go to make a left turn. So he would go left turn. And so the aircraft would turn left, okay? So then he would go neutral position. All right, so now we're going to talk about the secondary flight controls, and in this case called the flaps, okay? This aircraft handles like this. The flaps have the degrees marked in on the gauge next to the actual flap handle. It's 10 degrees, 20 degrees, and what they call full flap at 30 degrees. Okay, so when the pilot needs to use the flaps, he would just push the flaps up, and the flaps come to 10 degrees. And then we're going to step outside and take a look at this. Is what 10-degree flap looks like. And so the pilot would use the secondary flight controls when he's coming in for landing or taking off, and he would come in 10 degrees flat. Or if he wanted to lose altitude, he would go heavy flap. So that's a 10 degrees flap. 20 degrees flap would look like this. The pilot would put in, and you see how it drops down to 20 degrees, okay? And then full flaps, which is 30 degrees, is major difference. So you can see the difference between 10 degrees, 20 degrees, and 30 degrees, and that's going to really create a lot of drag and slow the pilot down. And if he's done, when he needs to lose altitude or he's getting ready to land, he pushes up and flaps up, and they retract back into the wing. And that's your secondary flight control. All right.